Hello everyone, myself Dr. Anchal Agarwal. Firstly, I will tell my qualifications. My qualifications are I have done my BSc Honours in Mathematics and MSc Honours in Mathematics from Punjab University campus. And then I have done my PhD in Mathematics. And during PhD, I have four publications in international journals. And after PhD, I have one publication. Then I have also qualified CSIR NET three times and GATE three times. Then I have taught IIT JEE Mathematics for 2 years in some institute. Currently, I am working as assistant professor on contract basis in mathematics department in Guru Nanak Dev University, Amritsar, in campus itself. This is my content plan. We will cover complex numbers in 3 hours, then we will do binomial theorem that will be covered in 4 hours. Similarly, sequence and series will be covered in 4 hours, straight line will be covered in 3 hours, circles will be covered in 4 hours, parabola in 2 hours, ellipse in 3, and hyperbola in 3 hours. Then we will do permutation combination in 3 hours. Mathematical reasoning will be covered in 2 hours. Trigonometry function and inverse trigonometry function will be covered in 9 hours. This is my content plan. uh, this is how many hours we will take to cover these topics. For example, a pair of straight line will be covered in 2 hours, matrices and determinant will be covered in 7 hours, limit, continuity and differentiability will be covered in 8 hours, and similarly differential equation will be covered in 5 hours and probability will be covered in 4 hours. Now we will do complex numbers. Firstly, I will introduce why we need these numbers and what are its importance. If we see this equation x square plus 1 is equal to 0, we can see it has no real solution, because if it has a real solution, then square of that number will be minus 1, but we know square of any real number can't be negative. So we get that this equation has no real solution. So we need to extend the real number system to a larger system so that we can find solution of such equation. In this chapter, we will define system of complex number, which shall include not only real number but also square root of negative numbers. In real numbers, we have seen square root of only positive number. We have discussed about only square root of positive numbers. In complex number, we will also see what is square root of negative number. Firstly, we will see imaginary numbers. Consider this equation x square plus 1 is equal to 0. We can write it as x square is equal to minus 1. If we take square root, we will get x is equal to plus minus under root minus 1. The number under root minus 1 is not a real number, so we call it imaginary number and denote it by iota. So iota will be under root minus 1, and if we square on the both side, iota square will be minus 1. Now we will find square root of any negative real number. Now we can see under root of minus 1. We can write under root of minus 3 as under root 3 into minus 1. And we can part it away under root 3 under root minus 1. Under root 3 into under root minus 1, we have put iota. So this will be under root 3 iota. Then under root minus 36, we can write it as under root 36 into minus 1, which will be under root 36 into under root minus 1. This will be 6 iota. So we get to know how to find square root of negative real number. Now we will see the expression under root AB is equal to under root A under root B only is only true if at least one of the values of A or B is non-negative. If both A and B are not negative, then this expression is not true. We can see it by this example. If we know under root of 36 is 6, and under root of, we can write 36 as minus 4 into minus 9. If this expression hold, then under root of minus 4 into minus 9 will be under root minus 4 into under root minus 9. And we have seen above, this under root of minus 4 will be 2 iota, and under root of minus 9 will be 3 iota, which will be 6 iota square, that is minus 6. 6 is not equal to minus 6. So we can see This expression under root ab is equal to under root a under root b only true when at least one of a or b is non-negative. Now we'll see integral powers of iota. Since iota is equal to under root minus 1, so we can see and iota square will be minus 1 and iota cube will be minus iota and iota fourth power will be 1. Now if we want to find out higher powers of iota where n is greater than 4, we have to apply a division algorithm on n and 4. If we divide n by 4, then we will get by division algorithm n is equal to 4q plus r, where q is my quotient and r is my remainder, such that remainder will lie between 0 and 3, and iota power n will be iota power 4q plus r, and we have this will be iota 4q into iota power r. Iota 4q can be written as iota power 4 whole to power q into iota power r. We know iota power 4 is 1, so this will be iota power r. So in general, we get higher powers of iota for n greater than 4. This will all depends on lower iota square, iota cube and iota power 4. So in general, we can see iota power 4n will be 1, iota power 4n plus 1 will be iota, and iota power 4n plus 2 will be minus 1, and iota power 4n plus 3 will be minus iota. Now we will see some questions. If we have now we, if find the value of iota power 125 and this expression, firstly we will divide 125 by 4. We get iota power 4 whole to power 31 into iota. We know iota power 4 is 1, so this will be iota. And this expression 1 plus iota square iota cube, put the values of iota square and iota cube, we will get 0. Now we have to solve this equation that we have initially seen ki, that is it has no real number. X square plus 1 is equal to 0. If we solve it by x is equal to minus b plus minus under root d upon 2a, we will get its solution as x is equal to iota or x is equal to minus iota. Next, now we are in condition to define what are complex numbers. Uh, Above we have seen why we need complex numbers and why we need imaginary number. Now we will see what are complex number. Consider this quadratic equation. After solving, we get its solution as x is equal to minus 1 plus iota and minus 1 minus iota. So we get minus 1 plus iota as solution of this quadratic equation. If we see it closely, we can see it has two numbers, minus 1 and iota, combination of two numbers, that is minus 1 and iota. But we know minus 1 is a real number and iota is an imaginary number, and we can't add or subtract real number and imaginary number. So we can say this plus or negative sign between numbers is just a expression, just a sign to combine two numbers. Okay, so this is just a symbol which is connecting two numbers, real number and imaginary number, which has some grammatical interpretation that we will see. So in general, a number of the form x plus iota y, where x and y are real number, is called a complex number. Here x is called a real part of z and y is called imaginary part of z, and it will be denoted by re of z, im of z respectively. Complex number z is equal to x plus iota b can be also thought as, this is geometric interpretation, we can thought it as a ordered pair of real number x comma y, where x will denote number on real x is x and y will denote number on y axis. Some examples of complex numbers are 2 plus 3 iota, minus 1 plus 2 iota, 0 plus 2 iota, minus 1 plus 0 iota. If we see last two numbers, we get 2 iota and last number is minus 1. We will see these are purely imaginary and purely real number respectively. We will see if in z is equal to x plus iota, x is equal to 0, then z will be called purely imaginary number, and if in z y is equal to 0, then z is called purely real number. So set of real number is subset of set of complex number. Next note, Inequalities in complex number are not defined. We can't compare, like in real number, we can compare two real number, which is greater, which is smaller. But in complex number, we can't compare two numbers as iota is neither positive, zero, or negative. So comparing two complex number is not possible. So this expression is not possible. Now we will see when will two complex numbers are equal. If imaginary part and real part of both complex number are separately equal, then we say two complex numbers are equal. So if x is plus iota y is equal to a plus iota b, then x is equal to a and y is equal to b. The complex number 0 is purely real and purely imaginary both. Bilkul. Now we'll do one question. You have to find real values of x and y for which complex numbers these are equal. If we compare real parts and imaginary part of both complex number, we will get x is equal to -1 and x plus y is equal to 2. Put the value of x is equal to -1, we will get y is equal to 3. Next, these are my algebraic operations on complex number. Like in real number, we add two number, we subtract two number, multiply and divide two number. Similarly, we will see how to add two complex number, multiply two complex number, or divide two number. Let z1 is equal to x plus iota y and z2 is equal to this be two complex number. Then how z1 plus z2 will be real part of z1 plus real part of z2 plus iota time imaginary part of z1 plus imaginary part of z2. Similarly, subtraction can be done. Now multiplication will be done. Z1 z2 is equal to, we will multiply it by each factor and we will get this expression xz minus yt plus iota xt plus yz. And similarly z1 upon z2 will be done by, we have multiply or and divide by z minus iota t and we get this expression where at least one of z or t is non-zero, because if both are zero then this z1 upon z2 will not be defined term. Now we'll see what is conjugate of complex number. Conjugate of complex number is, if we have complex number z is equal to x plus iota y, then its conjugate will be z bar is equal to x minus iota y. For example, z is equal to 2 plus 3 iota, then z bar will be 2 minus 3 iota. If z is equal to 4 iota, then z bar will be minus 4 iota. Thus on complex number for ordered pair x comma y, its conjugate will be x comma minus y. So we can see this is reflection of x comma y in real axis. So we can see conjugate of any complex number will be reflection of that number in real axis. Now these are some properties of conjugate. Z conjugate, conjugate is again z, z plus z conjugate is 2 times real part of z, z minus z conjugate is 2 iota imaginary part of z, and similarly other properties. We will do one question which will in which we use these properties. Question 5, prove that this expression is purely real. If we write this expression as 1 plus iota power 5 plus, we can see 1 minus iota is conjugate of 1 plus 1 minus iota, 1 plus iota. So we can write it as 1 plus iota power 5 plus 1 plus iota conjugate power 5. Now apply 10th property. On applying 10th property, we will get 1 plus iota power 5 plus 1 plus iota